Good morning, everyone. Welcome to CU Land Wednesday meeting, CWM. Today is January 26th. Well, looks like almost the first month is gone already. And beginning of this year, we today, as we announced, we invited Sean Lee, is the president of Prime Choice Home Inspection. And also thanks for the sponsoring for our year-end party. Sean Lee gave us the one free condo inspection, like a coupon. So I think I don't remember who got that, but appreciate Sean Lee. Okay, so I want to hand it over to Sean Lee again. You may ask any questions, but I come up with 3 questions, primarily 3 sort of area. One is the stucco exterior. And the second question I prepared is, how are we going to measure heating and air conditioning is working well? Okay, they can say, okay, it's working, but how well the system is working? And the third question I prepared is, there's a watermark often, let's say, leaking. And how do we know it's active? Right now, there's activities leaking, or is just a watermark from the past incident. Okay, so right now is okay. So how are we going to distinguish? Okay, so Sean Lee, I want to hand it over to Sean Lee. Okay, so yes. I will hand it over to you. Yeah, go ahead. You can introduce yourself.
Hi, this is Sean. I think some of you may know me already. And if you didn't see me before, nice to meet you. And I've been doing home inspection for the last 20 years. And I'm probably the oldest, the Korean home inspector in the market right now. But so I hope see you in the future so many times. So today, Mr. Lee asked me about 3 questions. The first one is the synthetic stucco. We call that EIFS, EIFS. I don't know if you see that in the presentation. Yes, on the first diagram, we call synthetic stucco, EIFS. It stands for Exterior Insulation Finishing System, EIFS. This was in the market for many years. In US, we didn't have it for long. It was very popular between mid-90s till about mid-2000. So it's been very popular in the past, but about 10, 15 years ago. But since then, we actually moved out of this system. So we don't use this anymore most of the time, at least in this area. In other parts of the US, they may still use it, but we are very much out of this system now. But there are many houses that still uses this and they still have it. And the problem with this system is basically the water penetration. Let me tell you something about this before before I go on to the problem of the system. This was mainly introduced in Europe after the World War II, and they were moving on to more industrialization age, and they were concerned about the insulation of the house. But most of the houses in Europe are old, and they're masonry product, such as bricks and concrete and all that stuff. So they didn't really have any insulation in the outside or any of the walls. So they came up with the idea to put the insulation outside of the house, sort of encapsulating the entire house with the styrofoam. And so if you see this diagram here, and in the back here it says the sheeting, the plywood, OSB or gypsum board. And in front of that, they put a polyethylene plastic foam, which we usually call the styrofoam. And that's typically about 3 inches thick. And it's about 3 feet and 3 feet in the size. And they fasten it to the, on this diagram here, it says plywood, but that's like modified in the US. But before, it used to be attached to a masonry product on the outside house. And then they have to coat it because the styrofoam itself is not going to withstand the weathering. So they have to put a fiber mesh in the front, and then they do a couple of coats on top of it. It's the stucco. It used to be a cement. Now they use a polyethylene product, which is already colored and textured. So Mr. Lee, if you can go down a little bit with the picture that we have. Actually go down to the one that you sent me to.
Okay.
All the way
Before
down.
we go further, I have a quick question. So this stucco is not a popular exterior anymore in US?
Well, we still do, but we actually do a different way.
Oh, okay.
Okay.
All right.
So we go down there, and this is a good picture that Mr. Lee sent me earlier. See that the white foam inside and little mesh and the coating on the outside. So this is a typical of the EIFS product, and this is a typical damage as well. It's corners around the windows, chimney stacks. It's a lot with, this is actual physical damage. So you can actually see this. This is very easy to see, and you can tell there's a problem. Now, the bigger problem actually, what happens is the water actually goes behind the styrofoam, and it goes between the plywood and the styrofoam and trapped. And so water gets trapped in behind the visual area, and it starts rotting the wood product within the wall frame. And that's a bigger problem. If you go up a little bit, the other picture that I sent you, you can see that these stains on the outside of the wall, and you can actually tell the lines going square like that's vertical and horizontal. If you go up another one, that's actually showed it better. Yeah, that one. You can actually see actual lines going on the wall. These lines are basically the seams of that styrofoam that was attached into the wall, and the rotting and all that moisture is trying to escape through the seams of that styrofoam, and that's what's leaving these lines on the wall. And this is pretty obvious, and sometimes these lines are very faded. You can't really see well. In certain condition, you won't probably see it at all. So this is a clear picture. So I just wanted to bring a example to you. But most of the time, as an inspector, we don't really see it either.
Sean, I have a quick question too. So this is kind of a pre-existed panel. There's a certain size.
Yes, typically the styrofoam is attached to 3 feet by 3 feet in size, and they also cut it to fit the corners, such as the windows and doors. So if you look at these walls here, and you can actually tell, like on the left corner of a right window, you can see the lines are about that size, 3 by 3, and next to it, it's another 3 by 3. Like in between the window, the bottom windows, you can actually see the actual the lines, the matching the size of the styrofoam. And you can actually go up and down. It looks about the same way. Right. So this house was in Inglewood Cliffs, and it was a close to $2 million house. And that deal obviously didn't go through well. But in the worst case, the entire siding will have to be removed and reapplied, and you have to replace entire sidings. That probably costs you close to about 40 to 50,000 these days. Used to be about 30 to 40,000, but things are more expensive these days, right? The other thing is that this house was extended, like was built up from the existing house, and they applied this in early 2000, and it took about 15 years to show up. So the problem is like slowly progressing without being noticed for many years. Typically, it takes up to about like any minimum 10 years, up to about 20 years before any problem starts showing. So that's another problem. So if you bought this in new house in like 2000 or 2004, something like that, and you had no problem for first 10 years, and all of a sudden you start seeing this, and people understand this. Oh, this is just a stain, so they can just wash it off or just paint it over. But that's not the end of it. It actually is behind the wall. That's the biggest mistake you can make. The person who were trying to buy this house also thought this was just the stain because there's like trees, and they just thought it's a mildew. Yeah, it's part of it is a mildew, but it's more than that. So how do you recognize this if you go out and see this house? How do you know this is what it is? You can tap on it. You can tap on the wall, not hard, but like lightly. It's just like a knock on the door. You hear the hollow sound on the wall. Okay, so because of the styrofoam behind, you can actually hear the whole like hollow sound behind. It's different. Now, the reason that it's happening here in U.S. more than in Europe is because, again, as I explained earlier, in Europe, the older houses had a masonry product on the outside, like a brick walls outside, and they can put these things on top of it. And even if the water gets behind, it's not a problem because the mason behind. But here, everything is wood sheeted, and once water get behind, it's more the problem. So what we did, most of the contractors did, since we had a lot of these problems, they moved on, and they actually moved on because they couldn't give up on the look. So instead of putting the plywood behind, they start putting the concrete sheeting behind. You know, those what we call the Becker board, the concrete board, that we used to have it behind the bathrooms, like in the bathroom top walls before you put the tiles on. These concrete walls can put on. So they start putting these concrete walls instead of plywood, and this actually solved a lot of problems. So again, if you tap on these walls and new type of walls, you don't, the hollow sound is gone. It's more of the strong, rigid sound. That's how you differentiate it. Okay. Right. The other issues with this type of siding, it actually get damaged very easily if you because it's styrofoam behind. If you have a physical contact, like strong hitting, surface get damaged like so easy like this. And they try to cover it with a little resin on the top, but that's not going to solve it. Most likely, you'll have to cut this out and put a new piece on and refinish it. Then again, you'll have a hard time matching the colors. The other most common issues is that you're going to find the round holes. These are woodpeckers. It sounds funny, right? Woodpeckers make a lot of sounds on the wood by pecking on it. They're trying to find the insects. Sometimes there are insects behind the wall. They also do a mating ritual. So they're trying to make a large, like, hollow sound to attract the mate. So that's another thing. They usually do that on the chimney stacks. So we do see a lot of those too. Any questions about these walls?
Okay, it's kind of very interesting. I didn't know a lot of stuff. Probably last question about the stucco. So why they use this stucco? Because of it's a better look. They can put
So,
color.
as you know, that we've been improving the way of building the house in a way that we can save a lot of energy. Like we still do. There's energy saving rating systems even these days for newer houses. So the builders are constantly looking for the way to improve the energy rating of the house. So this was one of the moves they did. Because they encapsulate the entire house with the styrofoam, the insulation factors are much better. Because if you go back to typical way, you have a stud wall, which is a wood frame going up and down, and you put insulation between those wood um, stud, and that wood stud itself is a thermal break. So it actually touches the inside and outside wall on both times. So that becomes a cold spot. So if you cover entire outside, that styrofoam is giving you much better insulation. That's why they took it in the first place. Obviously, the better look or more premium look is another reason too.
I see. Okay, it's very, very good. I got a lot of stuff from the explanation. Okay, let's move to the next question. Let's say there is an AC system or a heating system. So the owner is saying, yeah, it works, it's fine, and then we can feel it. But
Right.
actually, there is any kind of a numbers or how well this system is working, etc.
Right. So first of all, they're like air conditioned central, like mostly we're talking about central air. So the central air is typically you have a compressor outside and you have an air handler inside the house, and that runs the house air through the cold surface, and that's how you get the air condition. What we do is we measure a temperature. So there is a return, the house air that returns to the system, and there is a exit point, which is a supply coming out of the system. So we measure the temperature between intake and the supply. What we're looking for the air condition is typically 12 degree or more in difference. So let's say the house air was like 72, and it should come down to about 60. That's a minimum. The new system typically drops about 18 degree, up to about 20. But if you have a more than 20-degree drop, that is a problem too. So what happens is that it's a little ironic, but basically you're cooling the house, but the house air is warming the system in the other way. So if you're having too much of air temperature drop, it means you don't have a good airflow through the system. So typically it starts forming an ice. I don't know, probably not many of you will remember this, but in old refrigerator, we used to have a lot of ice forming in the freezer, and we have to go through the defreezing or defrost cycle. I don't know if you remember this. So the air condition is something very similar to it. So you will have to pass these surface to drop the temperature. But if you drop it too much, you start forming an ice, and you're going to have a poor air condition at the end. So that's another sign of a problem. So that's for the air condition. If you don't have a minimum of 12 up to about 20-degree drop, the outside of that range typically is a problem. That's how you could understand. But I don't think many of you will carry any temperature measure, but I do. So by looking at it or by feeling it, it's very hard to say. All right, so moving on to the heating system. So unlike the air conditioning, the heating, we have many other different type of heating systems. So first thing is a forced air system, which typically connects to the air conditioner as well. So the label that Mr. Lee just shows up is just one of those systems, and this is a type 1. I don't want to go so much details, but there's a range already marked on the label. So this, I don't know if you can see it in the bottom, going down a little bit to the bottom, it says a temperature range. Maybe it's too small. But typically between 30 to about 50 degrees. So let's say if the house here is at 670 degrees, so you could go up to about 102 to 122, something like that. So what we do is we measure the temperature again. I'm sorry, that said a 30 to 60, right down to the last line to the right says a 30 Fahrenheit or 17 Celsius to about 60 Fahrenheit to 33 Celsius. So that's a temperature rise, which means that the air from the house and coming out of the register, you see about 30 to 60 degree in increase. That's a normal range. If it's a less or obviously or too high, that's another problem too. But all that, and again, you're probably not going to be able to tell this. And every unit has a different range, different design. So I obviously you're probably not going to go in this detail. Okay. Now moving on to another heating system, another type of heating system, which is very popular in this area, hot water system. This is a boiler that heats the water and then circulates the water through the baseboard, a water radiator, sometimes connects to the air conditioner as well, but basically it's a water heating system. The boiler system typically has an upper limit. So water itself has to be a certain temperature. It cannot be more than 180 or 190 degree. This is because if you heat the water too much, it boils. Boiling water creates the steam, and the system's not designed to take the steam into the pipes. So that's why they have a limit switch. And when this happens, typically there's a discharge valve next to the boiler, and that usually emits the water out, and you will see the water on the floor. Or some sort of leak in the system. Right. So again, that's like if you carry the thermostat, it'll be easier to tell, but without that, you might not be able to tell this. A lot of boilers actually equipped with a dial. I measure temperature measure. It shows the temperature as well as the pressure of the system. But that's not for you to see, but for us and the technician to see. So that's how we tell. The other system is obviously a steam system, which is basically boiling the water and steam goes all the way to the radiator. You'll hear the hissings and all that stuff. Yeah, that's way up, and as long as it's heating, that's enough. If you don't, sometimes these radiators, some radiators get heat, some radiators don't get the heat, and that could be a problem too. The only way to tell is the touch for you, but I can measure it different ways.
Okay. So I have just a kind of a summarizing question. So if it's a AC system, you're saying too soon, too much drop, temperature drop is not good either.
Right. So we're looking at for the air condition. Just to summarize it, For the air conditioner, we're looking for anywhere between 12 to about 20 degree drop in temperature.
From
So
current temperature, you put
right,
the AC and then it drops like a 20 degree or 12 degree. That's what you're
right,
talking about, right? Okay.
right. So minimum of 12 degrees. So okay, so let's say the homeowner said, "Oh, the air conditioner works. I mean, it's no problem. I always we get the cool air." So like if you get 10-degree difference, you're still gonna get cool air. But is that good? No, it's not. In that case, the system is gonna run consistently without stopping because the system's gonna work very hard to meet your need. And
Mhm.
it's not dropping enough of temperature. It's just gonna constantly run all the time. That's the problem. Right? And even lower, like a 4, 6, 5 degrees, and that's like almost you don't feel anything. But if you put your hands onto the register, and you probably will feel a little bit of coolness because the air is actually flowing, and as long as it drops the temperature, you may feel a little bit of coolness. But that's not how it's supposed to work. If it drops too much, that means that you don't have that's another problem because eventually you're going to have a ice forming within the system and you're not going to have a lot of cold coming out.
I
It's
see.
almost like you have an iceberg and blowing the air and you're trying to get a cool air out of it. It's not working.
I see. So typically like a 10-degree drop or 12-degree drop is pretty okay.
Right.
Pretty good. Okay.
Yeah. For the
Okay.
heating, it's got a range, but I don't think that's really a major concern for you. As long as you get the heat out of baseboard, the boiler works without any leak. You should consider that it's working fine.
I see. Okay. Appreciate it. The last question I had is how we see often the watermark from ceiling or wall or
Right.
so how do we know it's currently is active or it's something already done in the past and we see the watermark?
Okay. So this is again, it's very hard to tell by looking at it. Obviously, to identify the water stain is the first step. Um, so either it was a leak in the past or it's leaking right now. By looking at the stain itself, you might be able to tell that it's old, like the stain itself is faded out and may be old. If you see multiple lines of frontier, like when the waters are seeping out on the walls or ceiling, it's getting wet from where it started, and then it sort of like fades out. When it dries out, you'll see the end line, like a frontier of those watermarks. And if you see multiple lines, usually means it happened more than one times. Um, and and the next step we usually do is that we use the moisture meter, things like this. I don't know if you can see this. It tells you if there's a moisture. So right now, let's see if I have an example or something. Let's see, this is a clipboard, and if you put this on, and it doesn't show you any moisture, but if I put my hands behind, so my hand is actually wet inside. It's dry on the surface, but it's wet inside. So this is how we tell. This is what we call the moisture meter, and the old inspector is supposed to carry this in New Jersey. By the way, it's a rule. So this is how we tell. We put this on the surface and tell, or we have a penetrating pin in the top, so we can actually put on the top here, and actually shows a little bit too. But I can't really poke my hands, so I'm sorry. This is how we tell them. The other way I do is what we call the infrared camera. I carry this to the job. Again, not every inspector will carry this. This is not required by the state to carry. The one reason it's very expensive. These were mostly used by the firefighters, and they're trying to find the hot spots after the fire. They're trying to find if there's anything left behind, or they're also trying to find where it started. So this tells you, I don't know if you see this, it's my hand is hot, right? And behind me, it's like this, it's void, and it doesn't show much. So I can tell by the color that what is cold, what is warmer, and the water usually leaves a cold spot. So if it's leaking from the top, the water generally is colder than the surrounding, unless it's a hot water. So I usually I'd be able to tell. And what I do is I usually scan with this machine, ceilings and the walls, and if I see some spot, then I go with the moisture meter to confirm if it isn't wet or not. Because the surface, this is only telling the surface water, and it doesn't tell anything inside. And sometimes it works the same way, like cold weather like this. If you scan these around the house, you'll see the cold spots all around the house, like this. I don't know if you see, this is the corner of my room, right? You can see that the ceiling, this shows a little coldness, right? And that is not the water; it's just the cold surface. So you have to know how to use this, but that's how we usually do, right?
Okay, great. Well, I think so went over 30 minutes. If you don't have question or if you didn't prepare, of course you can contact him, by email or phone call, etc. So I really appreciate Sean your time today, and also
Okay.
appreciate your gift for our year-end meeting. And someone among us got the free two-bedroom condo inspection coupon. So
All
I
right.
really
Good.
appreciate it. Okay.
Yeah, I'm looking forward to see one.
Okay,
Great.
sure. All right. Thank
Great.
you. Okay.
Thank
Bye-bye.
you, and Happy New Year and prosperous year for everyone.
Thank
Thank
you much.
you.
Okay.
All right.
Bye-bye.